Hello and welcome to the world of NDE 4.0. My name is Johannes Rana and today is a great day because today we have a really great guest to this channel, Kimberley Hayes. Kimberley has by now 25 years of experience in NDE with background from ITW. I think it was about 18 years. She was the Global Business Development Manager for Olympus for a couple of years. Currently, she is at VMI. What I really like about Kim is that she's really passionate about innovation and about NDE 4.0. And the two of us have the honor to actually both serve on the ASNT NDE 4.0 committee as the vice chairs, besides our chair, Rippy Singh. She also is very active in ASME. For example, she leads the group on assisted analysis, which I think is a great help for all the developments we have on NDE 4.0. But today she will talk about a different topic. So Kim, here you go.
All right. Well, thank you so much, Johannes. I love this topic, and it's kind of fun to get it out there for all of us to kind of get our arms around. But probably in a year from now, it's going to be old news as the marketplace itself is moving quite rapidly. But so the topic today is really on digital dynamics, but with an emphasis on the importance of global collaboration, and that being not only geographically global, but also global within the vertical silos of different industry. We all have to engage in this momentum forward. So just again, a little bit more about me and thank you for the introduction on it, Johannes. And yes, about over 25 years in NDT. Got undergrad in science, master's of business, but the most exciting things that are in the purview of this topic was last year I had the opportunity to take a certification through MIT for artificial intelligence business strategy. And just this, I'm just now enrolled in the artificial intelligence business applications with the University of Texas, Austin. So about a 6-month course just to try to get a little more exposure to this dynamics, kind of to couple with the NDT market. But as you mentioned, codes and standards activity, and that's important to not only understand the implications, but also try to be a part of some of the evolutions that keep it relevant to technologies that keeps coming on board. In this topic, I'd really like to start with the end in mind. And one of my favorite statements is, if you change the way you look at things, the things you look at change. And that's the way we need to look at this industry in general, although it's been very latent and consistent in its path for the past decades. It's now been thrust upon it to try to reevaluate how we position NDE and inspection and structure health monitoring and other tools that come online and outside of the conventional legacy ways we've done it before. And another thing is, I like to kind of say is that do not focus on the 3/4 inch drill bit. People really want to focus on having a 3/4 inch hole. So various technologies and tools may be different. They're not so interested in the GUIs or the interface or the progressive developments of the hardware they're familiar with, as much as they are what's the best tool for the best job to get the right results. And also we need to look at how, we need to break the mold. As I was saying, the technology of now has kind of created a different technician. They're going to possibly have VR and other types of wireless remote and drones and robots as tools to accompany them. And how do we interact with those tools to really focus on acquiring the data and let the technician and all focus on the results and their expertise. So it's that compatible and collaborative that the industry is going to be migrating to. Plus, what are going to be the impacts of the digital twin and data analytics? And so the emphasis is shifted away from the physics, not so much away from the physics, but about the importance of the data and what that data is telling us and how are we using it after the acquisition. So today I'd really kind of like to run through a high level on the considerations when developing a strategic plan to capitalize on NDE 4.0. It's always good to kind of start off with what is Industrial 4.0. And when I use the term value chain, what really does that mean? And how do we really get that adoption and acceptance throughout that connection? And the innovation path might be iterative, and just kind of a little highlight on that, and a little bit on the cases and codes and committee efforts. And I just kind of wanted to highlight specifically radiography, which was one of the reasons I came over to VMI, was to try to get purview into the method that's got probably one of the oldest legacy entrenchments, and it's still kind of running as it has for the past 75 years. And then kind of tee it off for question and answers that hopefully we can circle back around on a future YouTube. If that's all right, Johannes. Awesome. Okay, so Industry 4.0, you know, the one thing that's kind of interesting is there's so many definitions running around, and so many different applications and processes that it impacts. So really trying to hone in on our space in Indy E4 or Industrial 4.0 kind of brings that subset down. But it's not a panacea that's going to solve every problem. And it's important to understand that it must be scalable, and we must be agile and willing to kind of do these iterative progressions. But the most important thing I want to emphasize today is it's a collaborative sprint. These are and it's not, in my opinion, it shouldn't be used as a competitive front runner to differentiate different companies from one another if we really want to elevate it globally, and the adoption elevated globally. And, you know, Johannes and I've had the privilege to have some conversations with some international, some European standards and the US standards to try to make sure we all converge on agreeing on definitions. That's really an important thing. If we're not all on the same page from the start, like assisted analysis, what does that mean? What does that envelop? Then we're going to have a harder time building the tools and the building blocks from underneath of that. And we all need to kind of look at how we need to focus on a path for this adoption. And if not planned, can be daunting chaos with the digital as it continues to evolve. It's difficult to keep up. I mean, with even just from the drones entrenchment into some of our UAS into the inspection arena, but then you've got other things that come off of that, just magnitudes of data. How are we going to manage that? It might be a really good place for the assisted analysis tools and computer vision. And let the outcomes work in concert with the codes and standards so that we keep evolving. And when I think value chain, what I think is what is important to the value chain. And when I talk about that, I'm thinking owner operators with the on-site service provider, with the equipment manufacturers, basically throwing the business cards out the door and sitting in a room and saying, how do we need to be successful in the integration of our 5-year, 2-year plan. And in some of those cases, the hardware acquisition might be burdensome from the on-site inspection company. But if it's the plan of the owner operator to have digital data, then there needs to be some level of cost sharing in that, and not necessarily hammering down to the lowest bid of per wells through procurement, because that kind of prohibits and retards that development progression. But also in that is important to have the equipment manufacturer engaged to understand, you know, what data do you really need? How frequently do you need it? Do you need auto cals and forced, you know, different mechanisms, or you need to actually have a test platform where you can do it down before you actually do a product development roadmap, to where you can actually understand, do you just need a 0.00x measurement, or do you actually need the waveform? Do you need the technician information? So it's imperative that we have this transparent value chain conversation. But at the end of the day, back to that 3/4 inch hole and the 3/4 inch drill bit, this is what I've kind of been told from the owner operator's perspective is what's important. And there are 4 key pillars to this. It's reducing risk to examiners. So there's different ways that can happen. It can be through connectivity, safety and compliance conditions followed, or even training in those things, integrations into their system that you know, the risk to examiner, if they don't have to go into a pressure vessel and a robot can go in there and acquire that data, keeping the technician safe and outside of the vessel, those are all good for everyone, right? And so we got to figure out how do we really get that. And it's important that we train on the safety of the plant, train on the robotics, train the owner operator on the use of it and the value of it. Also, the increased data that can come in many ways. So, you know, when you go out and do a thickness measurement location, TML, you go out, you take a one single point measurement. The next time may not be consistent from when the next technician comes out on the next cycle, but there are alternatives like putting a permanently mounted sensor that can send on calculated intervals. Or you can have larger coverage areas going from single point UT, let's say, to a phased array where we cover more. And the importance of accuracy of that data and doing data fidelity checks. So being able to pull that data from the infrastructure RBI system and really kind of do on-spot check, kind of are opportunities that can kind of benefit the whole, and speed in which that data is gotten. And if you are able to have an in situ sensor, you know, that can be done minutes. So instead of having to deploy a technician to go out and do that acquisition. And then also biggest for the owner operators, they're they are focused on refining. They're not focused on how to do an inspection. The important thing is they need to know that they're running safely. And so, you know, they want to keep going without having to shut down a certain part of their operations. So maybe there are alternate screening tools, continued benefit of an in situ monitoring for even just to kind of keep a close eye to when your next turnaround, or if you can make it to the next turnaround. And then robots can kind of go in areas where humans can't, and also RBI linkage. And then also the overall decrease to inspection. So yes, it might be an initial capital upfront investment for some of these changes, but over time that kind of becomes a cost benefit for all. So all of that being said, technology seems to have an enthusiastic position for adoption. You know, our projections for the oil and gas industry in 2017 was 5 billion devices connected, with a projection of 50 billion by last year. Has that been met or not? What are the impacts of COVID and some of that? And then the end of 2018, installed base of wireless devices in the oil and gas is estimated to be 1.3 million units. And this year, it's stated that $48.5 billion in IT global spend in the oil and gas market alone. So you're thinking we're on a good trajectory. But then, you know, there's always a but in some of these situations. Gartner also states that it is revealed that 53% of the oil and gas companies have failed to implement IoT solutions and are not planning to do so. So you kind of wonder, why is that, right? Some of that's really a lot centered around cybersecurity. And it was stated in 2017 that 31 billion in investment in that arena. But probably one of the biggest things for the domestic US market, oil and gas, is the evolving strategies and intensifying digital ambitions have rendered the oil and gas IT operation models unfit for purpose. It's kind of keep trying to make that demand of an infrastructure that wasn't really built for that. And some of that may mean a complete overhaul, but which way do we go on some of those systems? So, you know, trying to look at how do we really address each one of these and check these boxes off is understanding the imperative aspects of the security. And so how do we communicate? How do we all in the whole value chain, as I was saying, work together to make sure we're trekking down that where that data continuity has, you know, all the rights, conditions to protect that credentials, and even global data sharing and regulatory compliances according to regions, the data segmentation and wherever it is in the cloud, the keeping that pure distinction between assets and asset owner differences. And then also, what are your data recovery protocols? Those are things we all need to be having open conversations about. And localize, you know, do we focus on localized access on-prem, or, you know, how do we really push things out to the cloud with confidence? And then multi-company data handshaking, like how does it go from the equipment to the platform for the inspection company to the owner operator's system. So we need to make those data very transferable, but very well protected. Back to the thing I like to emphasize, you'll kind of hear it in many different perception or different angles in this talk, but the importance of having owner operator, because again, they're focused on doing production, but they're wanting the outcome. Can I keep running? Is it safe to run? And then the inspection provider, they're the deployment pathway for these ideas, but they have the burden of proof. So ultimately the responsibility rests on their shoulders, and equipment manufacturers need to be adaptable, reliable, and a confident client in this whole discussion arena. And look at iterative adoptions, like the benefit of these systems that can help with technician workflow management, so that the human factor is mitigated, and kind of a support tool to kind of enforce that reliability, training, and then feature function development of different systems. So if you look at this iterative, you've got the scaffolding, where it's the legacy way of doing that, can be costly, time consuming, safety potentially hazard. Kind of went to where there was a high use of scaffold rope access in lieu of scaffolding, and a good cost savings from an initial standpoint. But since then, it's also moved quite rapidly into doing drones for the visual, or drones for the thickness measurement, robotics and those deployments, as well as in situ. So we just, going back to that whole thing, we need the 3/4 inch hole, not the 3/4 inch drill bit. So the importance is that thickness measurement, being obtained, but looking at various deployment tools and methodologies to get there that can help with the technician being trained across that process, as well as the owner operators, as well as the equipment manufacturers. We need to kind of back with the iterative part. And I think the NDE 4.0 is a really strong position for where those take off. So we, and back to kind of as the one before, in that iterative evolution, it's imperative that we kind of focus on the human factor part of this in the machine learning tools within the systems that can help with doing the data fidelity checks, as mentioned, auto push for the setup configurations and offline remote support, workflow optimization, so it kind of sequences the technician through, so each inspector goes through the same workflow process. And then looking at assisted analysis and auto discontinuity recognition to kind of help as a flag to areas of interest. But then how do we go about validating these technologies? And those are kind of important conversations that really need to go about. Is a PDQ okay, like a performance demonstration, or low thresholding PODs, where your probability of detection, or high threshold and high consequence areas, and what do those samplings and validation measures need to look like? So as we make that migration and validation of technology, we all have to have that explainable AI understanding, and so that it's not just a black box data output. So, and then the benefits the medical industry's kind of had over a decade before industrial, with the remote review for the, let's say, a radiographer, looking at your health records. Again, their conditions are a lot easier because you're 98% water and the structures are very consistent. But in the industrial industry, our industrial market, it's very diverse, from composites, wind turbine blades to airplane parts. And so we need to figure out how we can support that, and the security that's important there as well. And then, but one thing that back to the handshake and communication from the equipment manufacturer to the service company to the owner operator. And thank you, Johannes. I have one of your slides, give you the credit on that, kind of the importance of the raw data maybe going into this common format. It's been long out there, but I don't picked up as readily. And I think we're kind of getting there, where we're having less proprietary files that come out of the systems, and kind of focusing one that's a little more open source, or kind of consistent across in the incoming and outgoing aspects of it. So encouraging that kind of a global standard can help either the platform or the owner operator. We can all kind of focus on how we reliably transfer that information. So back to that kind of a brief thing. I won't cover too much of this, but it's important as you know, we really start writing these codes and standards that we really do centralize on common terminology. And so how do we do that? We just have to be very transparent and reaching out to our brothers and sisters across in different regions and converge and not just run one code to try to be that competitive front leader. It's just really not going to help the industry as a whole. So some of the things that are going on, and Johannes was mentioning, you know, that RIPI is taking charge on the NDE 4.0 side with ASNT. There's a handbook that's being published that can kind of help explain some of the documentation, the plethora of information that's out, to kind of converge it and gestate it down to a point where it becomes NDE related. And then meetings and subcommittees to kind of have these conversations and different sessions, and there seems to be a lot of articles that are going out there, but we need to kind of all keep it narrow and focused in how we go about this, and not just everybody wanting to get a splash or a name out there. And on the ASME, working with the Surface and the FMCTFM, one thing that's interesting is the UAS side. Section 5, Article 9 addresses remote visual. Well, that's a big player and an important part when you're dealing with UASs and drones and robots. So how do we take what was legacy written for the human, you know, 15 inches, 100-foot candles, no more than 30-degree angle of incidence, and converge that into a platform that's not measurable at that 15 inches, right? And so some adaptations will be coming out in July that kind of bring that in. And the beauty of that opportunity was it was through European research that kind of helped share within the ASME code to get kind of that final outcome. So back to the whole collaboration. Sprint Robotics, been a part of that since 2015. They do a great job of very transparent conversation about pain points, and then opportunities with people outside of industry, outside of NDT, to where we can all kind of sit in the room. Somebody over there may have robots, somebody over there may have drones, somebody over here may have sensors. But how do we really say, here's a central problem? How do we work together? Very different companies coming together to solve a very important problem. And various API activities going on as well. So like with pipeline, the large volume of data generated during a pipeline inspection is usually reduced to key indicators, while valuable information remains hidden in the intricate relation and trends between the data. So how do we really go through these things? How do we really, maybe the path is using supervised learning, where, you know, we all kind of converge on the classifications and then also get the input from the stakeholders. And algorithms can learn as we keep going, and then everybody increases their confidence and reliability in that technology, as it's more of secondary, kind of going along with legacy processes, but the confidence kind of can grow as it keeps getting consistent outputs that a inspector and an asset owner can actually agree with. So looking at like these migration paths, film is one that really interests me, or radiography in START. It's still, I think 75 to 80%, maybe even 85% still in North America is using film. And the inherent conditions that go with that are the cost of the rig. You have to have your vault area, your dark room. You have to have your chemicals. You have to have the technician inside of that darkened area. And new regulations are requiring different, more technicians, maybe 2 actually having line of sight and 1 inside doing the developing. So you've got extra manpower that can be eliminated or reappropriated. It's probably the better word. Reshoots, the painful points of that, you know, we won't find that out until after the film's processed. Then you've got the magnitude of file, the packets of the film, where in the digital migration, you actually have terabytes that can do the same. And sometimes the disposal costs of that chemicals can get had someone share it was like 5,000 a month in one of their regions just for that disposal cost. But the bidding process, in my opinion, often is based off of those already depreciated assets. And so it becomes a very cost minimal bid, and the ramp up cost to go down the digital pathway and the training of the technician and all of these things tend to keep that legacy process with a stronghold. And we might, that back to that early conversation is that sharing of the cost in some of these, migrations. And, from film, things migrated to a digital path of CR, which has been out for a while. It's still taking analog data, but it digitizes it. It invokes a greater sense of care to really capture the financial ROI because of the cassette management. The cassettes cost a lot more than, let's say, a packet of film, which is a one and done, but the cassettes themselves can be reused over and over. But it's important that the training go in alignment with that to minimize artifacts. And there are some scanning time delays, but in general, it's still a lot faster than film. And then the next migration has been out there, but not fully deployed universally, is the benefits of digital radiography. No darkroom is needed. You can pretty much go remotely and have a standard rented truck and go out and perform where you don't need a darkroom or a completely outfitted fleet. Acquisition quality, so you're not having to deal with the reshoot potential because you can verify on site right after the acquisition within seconds, right? Real-time data review, remote transmission, and you can be scanning in a remote part of the country and porting those files to multiple and various other regions of the country for all a collective review that you can't do with film. You have also faster response to the customer and travel cost reduced. That was kind of back to the whole not having to have a fleet of the darkroom. Data storage is very important. Quick upload to your mechanical integrity solutions, and very well suited for assisted analysis and auto discontinuity kind of screening on site. So yes, it's an initial upfront capital cost that's a burden pushed on oftentimes to the inspection company, but that's where the importance of the value chain working together for that long-term strategy to really offset that initial CapEx to make sure we look at the real value of where we're going collectively. So want to kind of end it with Madam Curie's final comments for this presentation, but a quote from her is, "Nothing in life is to be feared. It is only to be understood. Now is the time to understand more, so we fear less." I think with this whole buzz, as we kind of started the talk off on NDE 4.0, what is it? It's not a panacea. It's just, many, many different direct definitions. I think there's a lot of misconceptions and misuse, but if we all converge together with high level of transparency in our applications and our directions and our concerns, then we can probably migrate a little bit faster and basic collective elevation. So one of the things I'd like to, if it's okay, I'd like to leave it with is, if, it would be wonderful if you could share some of your applications, some of your lessons learned, some of your thoughts on where technology is going and how we as an industry and NDT can really look at the open communication pathways so that we do elevate the craft and the trade and the efforts by maintaining that level of quality that's so critical to our industry. And we do it collectively. So hopefully you'll share your thoughts, your questions, and any kind of comments that you may have. Thank you. Appreciate it.
Thank you, Kim. So for me, that was a fantastic presentation. Especially liked how you showed that we need the step, number one, to go digital, number two, for digitalization, and number three, also to digital transformation in some future. And now it's time for all of you out there to ask us questions, to ask us questions about this fantastic presentation, to ask us questions about, the digital or radiology becoming digital, and why perhaps you feel you still don't want to go that route, even with all the benefits we can see from going that route. So Kim, once more, thank you. We will, I guess, re-meet in about 3 to 4 weeks to answer all those questions, which hopefully all of you sent to us. And so, thank you. Bye.
Thank you. Bye-bye.